I also have to take attendance. Okay, let's see here. Cool, everyone's here. Perfect. Oh, another thing you guys could do too after we finish today, if you're missing any homeworks, I think you guys are pretty good with your homework. So this group is, it's my E period had to tend to have issues with turning homework on time or just getting homework in, period. But if you are missing any, if you notice any fives or anything like that, you could use this time also when we're outside to get caught up. But I think you guys are okay. I don't see it as an issue. But I do have to submit grades later today. So anyhow, let's start talking here. All right. So in the first couple of lessons, we investigate volume, surface, and split three-dimensional solids. We actually kind of did two lessons, right? If you think about it. Last time we met on Monday. And remember, they call these prisms, right? So now we'll explore different ways to find volume and surface area of a prism and a related solid called a cylinder. We'll also consider what happens to the volume of a prism or cylinder if it slants to one side or if it's enlarged proportionally. So let's look at 928. Examine the three-dimensional solid at right. On graph paper, draw a net that when folded will create the solid. We don't necessarily need to do that necessarily. I think you guys know how the net would look, so I'm not too worried about it. But let's consider the dimensions. How wide is this going to be? How deep does it go? How high does it go? Perfect. So we'll avoid A and B. Let's just not just cross those off. So we can, just move on to the part I really care about, the volume and the surface area and the volume, right? So let me move this up. Here we go. Okay. So surface area and volume. Okie dokie. Let's do volume. Volume is always the easiest. The best way to think of volume is like the number of blocks, right? Or length times width times height, or the base times the height, or again, the number of blocks. So what would you get if you did length times width times height? Yeah, 24. There we go. Pretty easy, right? And 24 cubic units. Okay. Now let's look at surface area. For surface area, let's do front, back, left, right, top, bottom. So, or if you really just think about it, didn't we just say you could do the perimeter? Let me do this over here. Let's keep it simple. Didn't we just say the perimeter of the base times the height? So if we're efficient about it, times the height. So what shape is the base of this solid? And what are the dimensions of that rectangle? So what's the perimeter then? 3, 4, 3, 4. What's 3, 4, 3, 4? Good, 14. And then times the height. Yeah, but so for some reason, answer key says something else. So hold on. Wait, something seems off here. Yeah, wait, what the perimeter is 14, right? Oh, then plus, right, right. That's the lateral area. I'm losing my mind. Sorry about that. Yeah, okay, so I wasn't fully honest with you guys. Okay, what did this get me? That got me the lateral area, right? But I also have to add two bases as well. My apologies. Okay, a little rusty here. Okay, so now let's go. Because I'm not doing your guys' colors. That's why I'm off today. All right, so 14 times 2 plus 2 times the base. What's the area of the base? 12, right? So if you put it all together, you should get 52. And 52 square units. Because again, what you're doing is you're doing the when you do the perimeter of the base, that gets you all the sides, right? Like the left, right, front, back, the lateral faces, right? That's what it gets you. So you have 14 times 2, which is 28, and then the base, 12 and 12. There you go, right? So we get 52. All right, so we're okay with that now? Makes sense? Cool. All right. Okay, let's keep on moving. Okay, it says here to redraw this. Before we do that, what do we have? We have so we just had a rectangular prism. Now it's a triangular prism because the base is a triangle. Okay, that's fair. Try to redraw this prism on your paper. One way to do that is to draw two triangle bases first and then connect the second. So you could draw it like this. What do you think I just did? What am I trying to do here? Yeah, and the offset, yeah, like, and I draw two identical triangles, but I offset the second one, right? Just a little bit. And if I connect it, you get the same thing. So that's one way of looking at it, just so you know. Um, okay. Now, if I go to the next page, I'll keep my diagram there. Let's find the surface area and the volume. Okay. Okay. So my base, remember my base is a triangle. So that's 3 and 4 as well, right? And that's 9 right here. Hope that makes sense, those dimensions. What would x equal? How do I solve for x? What would I do? Yeah, it's a 3, 4, 5 triangle, right? 100%. Good. Awesome. So x equals 5. Okay, so the perimeter, so when I find the surface area, it's perimeter times the height plus 2 times the base. So what's going to be my perimeter of the triangle? Yeah, it's 12. So 12 times 9 plus, and what's the area of the base going to be? Yeah, exactly. 1/2, 3 times 4, right? So you totally get 6. Good. So you get 108 plus 12, which is 120 square units. Yeah, go Reagan.
Is there always a
Great question. I don't know. Actually, we'll see the opposite in part D. Yeah, we'll see the opposite. It's an interesting observation. Yeah. Don't I won't say necessarily all the time. I'd have to think about when that threshold gets reached, but yeah, it's not necessarily. Okay, for part C, I'll erase my green yellow diagram here, but let's go back to using green. All right, the volume. Volume is gonna be the area of the base times the height. We already know the base is 6, the height's 9, so that's really simple. 54 cubic units, right? 108. Do you,
this time?
yeah, but what's your every base though? Do you have 12 or 6? Right.
Divide by two.
Right, because you probably forgot to divide by 2 for the base area, right? So it's gonna be half of 3 times 4. It should be 6. 6 times 9 is 54.
But if you do length with
That would so the reason why that works is because you're dealing with a rectangular prism, right? Because what's length times width? That's the area of a rectangle. But that won't work for this one because actually, if you think about it, it's half of a rectangular prism. Because what if I had two of these, right? And put them together, it actually form a rectangular prism, right? So, because right triangles are also half of rectangles because it's not a rectangle. For this one, that's not. Why does it work for rectangular prisms? Because length times width is the area of the base. What's the area of the base here? It's not length times width. It's half of length times width.
So like,
So in general, you always want to do the area of the base. Area of the base times that. That's all. That's actually universal anyway. Sure. Yeah, you could because it is half of a rectangular prism. That works too. Now let's look at part D. Okay, I'm gonna have you guys do this in your table groups. Now you guys get the idea. And you guys should know how to find area of a hexagon. We've done this already. So what you'll need is you need the area of the hexagon.
basic regular.
It is regular. I think it said so, no? Yeah, they did. Who's that? It's crazy. Pick it up. All right. Okay. So we're gonna do this. That's so annoying. Okay, I'm gonna figure out what the heck's going on here. Yeah, I'm gonna figure this out.
On edge, yeah, it's fine, right, they're like, they're can't find it. What stuff is that?
I don't know. I'm just trying to figure. Mr. Van's gonna take it down to Christian. So if you ever guys lose your phone, just go to Christian Medina. You always go to him. So okay. Anyhow, keep working on this. That was funny. All right, so our hexagon, I'll go yellow for the hexagon. And remember the side length is 4. So that's also 4 and 4. What would the base be? Sorry, the height. Oh, apothem. Call it that. Good. Yeah. So that's 2 root 3. So hopefully you guys can figure that out. We want exact form, by the way. Do you need a calculator? Yeah, here we go. Here, the sophomore's yellow for you guys. Yes. Hopefully you guys get 24 root 3 for the area of the hexagon. Cool. That's square inches. So the perimeter, what's the perimeter of your base, by the way? Each side's 4 and 6 sides. 24 times, and then you have the height is 7 plus twice the base. Base is 24 root 3. So you should be getting 168. And by the way, can I add 168 to 48? No, please don't do that. We talked about that already. So we'll leave it like that. We'll go exact form. And then for the area of the base, of course, that's 24 root 3 times the height, which is 7. The 7 multiplies what number? The 24 to 3. Good, 24, because the radicals, believe it or not, is actually an exponent. You would not want to multiply anything to that 3 unless you have the same radical next to it. So it's 168 root 3 cubic inches. So we got that. We got that. Yeah. So all these vibrant colors too. Okay, so you can see how it's an extension of what we did in the previous unit, right? We did all these polygons, but we have to use that knowledge to help us find the area of the base or whatever, and then find the surface area and volume and all that stuff. So we're okay? Feels okay? It's good. All right. Let's keep on moving. All righty. 9:30. All right. So Carter 1 is what the bases are, circular. Discuss with your team how to find a surface area and volume. The radius of the base is 5 units and the height of the cylinder is 8 units. So I'll give you the formulas that you need. So remember, your surface area is the perimeter times the height. Yeah. Yeah. Now the perimeter is circumference. And the area is pi r squared. And then volume is the base times the height. Okay, I'll let you guys figure that out, and we'll talk in about a minute. Okay. Um, that should be easy. 40 times 25 times 8, 200 pi. That's cubic units. Then surface area. The perimeter is 10 pi, right? That's 2 pi r. And what's the height? 8 plus 2 times the base. The base is going to be 25 pi, I think. So you should get 130 pi. You do all correctly. Okay, any question on that one? We're good? Cool. Let's keep on moving. Oh, this question, yeah, go ahead. Oh, I did 80 plus 50 because when I do perimeter times the height, the perimeter is 10 pi, like circumference, the height's 8. So that's the lateral area, like this part right here, right? And then the base, top and bottom, 25 pi, 25 pi, so I got to do twice, right? So that's 50 pi. And if you have 50 to 80, you get 130. Yep. Cool. All right, let's look at this one here. Cavaliere's principle. Yeah. Of course. Yeah. Here, good. Do you want more notes? Well, no, I have more. We can do more. We can just keep getting ahead and all right. Yes, it is. And then afterwards, you guys can take your homework answer keys. We can correct them outside, or you can work on the problems outside. And when we do leave, I ask that we leave through the stairwell this way, just so we don't disrupt the other classes, or they don't get jealous, because they will get jealous. Yeah, so anyhow, okay, let's look at Cavalier's principle here. Let's read through this one here. Cavalier's principle, Bonaventura. Cavalier sounds like an Italian dude. 1590 to 16. Oh, geez. That's like my age. That's scary. Was a mathematician who helped to develop calculus, but is best remembered today for a principle named for him. Cavalier's principle can be thought of as a way of finding volumes in a relatively easy way, right? So suppose you have a stack of 25 pennies, one on top of the other. You decide to slant the stack by sliding some of the pennies over. Does the volume of the 25 pennies even change? Well, no, of course not, right? So, I mean, I think that should be common sense, right? Just use common sense. Of course not. The volume of each penny never changed. So why would the volume of the stack change? It would not. So really, yeah, just use common sense for that one, right? If you take a stack of pennies, or like you can take those rolls like you get from the bank of coins, or if you go to a cashier or the grocery store or any store, if you have cash. And yeah, if you stack it, great. Fine, it's got a certain volume, but if you like kind of tilt it a little bit, or like a slinky, right? You could think of it that way too. Like that wouldn't change. Like it'd still be the same volume, right? So now let's look at part B. Would the same thing be true of a stack of 15 books? They slide to the side or twist some of them. Yes. So we'd say again, of course, the same thing is true. Yeah, again, we're just using common sense, right? So the volume will not change. So the idea of viewing solids as slices that can be moved around without affecting the volume is called Cavalier's principle. Okay, fine. Um, yeah, even if you took all the books and twisted them, who cares? It's still the same volume. Um, so using this principle, um, to find the volume of the cylinder at the right, note that when the lateral face of the prism or cylinder not perpendicular to space, the solid is referred to as an oblique cylinder or prism. So you're just going to do this, right? I mean, imagine these are all these like thin discs. So yeah, I mean, we're still taking consideration. So let's go and work this out. So you're simply just going to do this. Pi 5 squared times 8. Oh, yeah, 200 pi.
Hey, would Mr. Gurley like come?
We're still looking.
Or there's another lady. See you guys.
Yeah, but another person's coming in tomorrow, actually.
He's not. You think I learned?
I don't, that's not my decision. I don't know. I mean, he'd be a fine hire, but
Fine, but just
I don't know.
what could you have done better?
No, I'm not saying yes or no. I've only seen him teach once. It's hard for me to judge. I mean, but I don't know. I think we have because we have so many applicants. We should just keep looking just to be sure. I don't know. It's not my decision. So, and we're not. We could take our time, but if you guys liked them, sounds like you guys liked them. I don't know. So we'll let you know what happens. All right. All right. And you'll see. There'll be a new teacher here. All right. So how's the volume of this prison related to the one and same? They're the same, so it doesn't change. So that's what's happening with that one. Um, okay. Once you guys tried 932, kind of work that one out. Um, and actually, one thing that we may do, probably, if I planned this better, could have done it today. Be kind of cool to actually figure out the volume of the water in the pool, right? And then you might remember when the pool was empty. Did anyone see how it looked when it was empty? Like it looked kind of crazy, like how cavernous it is. So that's what we could potentially do. Also, like we could like measure the dimensions. I'm not going to go deep down and so someone wants to dive down and do that, huh? No, but like the slant, like because the pool is slanted also. Um, but I do have a picture of it when it was empty. So that's but that'd be kind of a cool little experiment to do to kind of figure out like, hey, how much water does it take, or how long do you have to let how long does it take to fill up the pool? So anyhow, but go and work this one out. Let's see what you guys get. And you got to do some conversions also. So Hernando needs to replace the hot water tank at his house. He estimates his family needs a tank that can hold at least 75 gallons of water. His local water tank supplies a cylindrical model that has that diameter, that height. If 1 gallon is approximately that many cubic feet, the terms of the supplier's tank will provide enough water because the family needs 75 gallons, right? Yeah, good. Remember, volume is this. If D equals 2, what's R gonna equal, by the way? 1, yeah. And you want to convert it as a decimal because it'll make it easier to compare it to this. So what am I doing here on the bottom? What does that allow me to do is when I multiply by this fraction. And it can convert to gallons. For those who are taking chemistry, you guys are in grams and moles. You know exactly what I'm talking about with sophomores, but I know freshmen have no idea what I'm talking about. But when you convert, you want the units here to cancel the units on the bottom. So therefore, you get the units up top. So that's what you want to do. You want to multiply that out. If you do that carefully, you should get 70.5 gallons. The one on the bottom? That's a conversion. So for example, what if you have like 24 hours, right? And you want to convert that to minutes? How would you do that? You put 1 hour on the bottom and 6 minutes up top. Correct, right? Because obviously you wouldn't want to do 24 divided by 6. That'd be a small number, right? How many minutes of 24 hours? It's actually 1,440. So you want to do it that way because you want the units to cancel. So you get just minutes up top. It's the same principle for that conversion. That's what we're doing.
Wait.
That's fine too. Same thing. Same thing. Yep. Actually, you didn't have to convert as a decimal. Wasn't necessary actually. So you get 70.5 gallons. So the answer is no. It would not be enough, right? Because that tank is not going to meet the family's needs for hot water. And trust me, you need more, a lot more than 75 gallons, but that's fine. Okay. You guys want to do another lesson? No? Okay. This is good. Good timing. So next, yeah, so we still got another 30-ish. It's perfect. Good timing. Okay. So yeah, let's go outside. You guys could just leave through that stairwell. You can take your backpacks with you, but all I ask is you guys hang out in the grassy area. From That's fine. If you want shade, that's all good too.